Charlie.
Didn't see that coming.
No, I was in full flow, wasn't I?
Yeah.
Just wait for everyone else to get back.
Does that mean you lose your screen recording?
No, I got it. I've saved it.
Right.
I thought it did, but I don't.
So we needed a value for the 4.6 resistor, so we chose 4.7. But you wouldn't ever go below 4.6, would you?
Not in that application. It depends on application, John. But if we're
Right.
trying to limit the current, then we wouldn't pick a lower one because that's going to allow more current to flow, isn't it?
Yeah.
Wait, what
Yeah.
the hell?
Who are we waiting for?
How much have we got left? I'm running low on battery.
Well, officially another 55 minutes, but we'll see where we are. How far we get with the simulation.
Oh, I
Yeah,
might stop
halfway.
talk.
You got a charger,
Almost.
ain't you?
Yeah, but I can't talk and charge at the same time.
Can you not?
On his
Not on
phone.
my phone. I can't talk through my computer, so I talk on my phone, but obviously. I could put on loudspeaker, I guess, maybe. I don't know. Let's give it a try.
You'll get some mad echoes. We can't be having that.
100% today. I thought this Zoom's killed me.
Who's missing? Nathan's here,
Yes.
Macaulay, Luke, Connor. Taylor. He's always last, isn't he?
Always.
Someone messaged this goon.
Yeah, send him a message.
I say just carry on without it.
I will in a minute. Right, here we go. We'll get here in a minute. Right, so we picked this 4.70 resistor. Yeah. And that's what we're going to use in our circuit. So what I'm going to do now is share with you my simulator screen. Good old Blue Peter fashion. Here's what I set up earlier. Okay. Yeah. So I've got two grounds, just to keep it fairly simple.
That ground is really annoying.
Got a DC voltage source. I'll explain what I've done with that in a minute. I've got R1. I need to change that to 4.7.
Is this the program you told us to install?
Yeah.
Yeah.
If you can.
Mine don't look like that for some reason.
Yeah, that'll be because I'm on a Mac and you've probably got it for Windows, haven't you?
No, I got the Mac one, and that didn't. I just come up with like a little box. I have to email to what it comes up as because I weren't sure about it.
Okay, well, we got some time between now and next time to iron out a few details.
Yeah.
But Regan's got problems with it anyway because of his version as Windows works in S mode or something.
Yeah,
So
I had that one, but you can make exceptions to that.
Can you? Well, maybe you can help him with that then, Connor, yeah?
Yeah.
All right. The diode I've used in the here is the one in the simple non-linear components. So it's no particular diode. Yeah.
I'm back.
So we're going to assume that that's got a maximum forward current of 500 milliamps. I've got an ammeter in there measuring the diode current, okay? And I've made the voltage of the source equal to what I'm going to call VS, because I'm going to control VS between two voltages. And I'm going to show you how to do a voltage sweep. So we're going to then create a graph of current against voltage. Yeah. Okay.
Yeah.
So we have a basic DC simulation that we've used before. That's just been put on there in complete default mode. Nothing's been changed on it. Okay. For the benefit of this analysis. What we now want to do is put on a parameter sweep. Yeah.
Yep.
And then we want to edit the properties of that. Just get that out of the way so you can see a bit of the. Right. We're going to do. You're going to do the DC simulation, and we're going to sweep the VS property, the supply voltage. Yeah. We're going to do it in a linear way. We're going to start at, for the moment, minus 10 volts. And we're going to end at, put V on there. We're going to end at plus 3 volts. Yeah. And then here's the number of times we do the calculation. So if you don't do enough, you'll get a graph of not many points. So we'll do about 300. That'll handle that. So it's going to do 300 calculations between 10 volts and 3 volts to make this graph up. Yeah. So it's going to vary this voltage, do all the calculations, and then we'll turn it into a graph. So I click on OK. And then I want to run that simulation. And do up here somewhere, that one. And then we want to pick a Cartesian graph. and I'm going to display the current on that graph with the red line. Yeah.
Yep.
So if we pick that up, we can actually make that a bit bigger. Yeah. Now, if we look here, this is the voltage, right? And when we hit about 0.7 of a volt, that's that forward bias voltage, we need to achieve at least 0.7 before the diode starts to conduct. And then as we go up and up and up towards 3 volts, we head towards 500 milliamps. Okay, because our resistor is slightly bigger than the actual calculated value, we don't quite get to the 500 milliamps. That's fine. We've just set that as a limit. Okay. What we haven't found yet is where the reverse breakdown voltage is. -10 is not enough to find out where we reach this reverse breakdown. All right. Remember, simulation, but we couldn't do this with a real diode, because if we went up to reverse the reverse voltage, we'd actually destroy the diode. But we can do it on simulation. So if we go back to our basic circuit and edit the parameter sweep so that it starts at -100 volts, let's see if that will help us find where the reverse breakdown voltage is. Nope, we still haven't got it. The only problem with this is that it does crush the forward bias part of the diagram up. So if you're going to use these, you'd probably want 2 separate ones, one for the reverse bit and one for the forward bit. We still haven't found it, so let's go and up it again. Edit properties. -200. Okay. I think we should have it this time. Nope, still ain't got it.
You have to update this one.
Sorry?
Go -500. That'll do the job.
I'll do -500 down. I'll just up the iterations a little bit.
Do you have to hit apply there, or does it do it automatically?
You don't have to hit apply.
It's not got much luck here.
Well, I'm sure I tried this last night and I got that before then.
Do you not see on the zero mark, it goes up? Are we going the wrong way?
On the 0 mark, yeah, because that's the 3 volts forward bias that we looked at to start with.
Oh, right.
We want it going down over here. Hang on, let's have a look at that. Pull it. Oh, I corked it now. What have I done? Buddy. Oh dear. Right. Just change this to 4.7. Who keep bringing my thing up the top there?
What?
That's all right. Every time I try to go to the menu, at I got it. Right. Simulations. Sweep. Well, that's cool. That's being a right pain now. Right, I'm going to do something else now. Right, gents, go back to our diagram. Right, and I'm going to change this diode to a model of a real diode. So let's get rid of that. Now, you've got real components in the library. Okay, so I'm going to change it to a 1N4148 diode. Make sure it's the right way round. Now that has, let's check on this other computer. If you're on Windows, you get another little box down here that tells you the main details about that component. You don't seem to get it on Mac for some reason. So the 1N148 diode has a maximum current of 300 milliamps. So just going back to our other slide, we got to do 300 milliamps hours. So we got to do 2.7 over 0.3 to get our resistor value. Can someone just do that, please? .7 divided by 0.3.
2.7 divided by 0.3 is 9.
Okay, we'll put a 10 ohm in there then. All right, yeah. So now we're actually analysing a real D1N4148 diode. Yeah. Other than that, the circuit's exactly the same as it was. And the reverse voltage on that, it tells me on the Windows one 75 volts. So if I edit the parameter sweep to 3 volts and minus 1,000, minus 100, we should see reverse voltage breakdown.
Hopefully.
Yeah, here we are. So there's the positive bit over here. Yeah, about 0.7 volts. And reverse breakdown starts at minus 75 volts here. So that's the characteristic shape. Over in this portion here, which is very small, we got the forward bias characteristics.
Whose
And over
dog is
here,
that?
That's
reverse
mine.
bias characteristic. Okay,
Yes.
yeah. So are you all okay with that? Is that useful? So what we could do, if we wanted to document that, we'd probably have to do it by starting off doing a graph between minus 3 volts and plus 3 volts. So we get a nice big look at the situation where the thing is in forward bias. And then afterwards, looking separately at the reverse bias situation. So there's our forward bias. When we hit 0.7 volts, current starts to go up. Yeah.
Got it.
Okay. Yeah. So you combine those two graphs together. They need very different scales. That's the problem. But you could superimpose them over each other. Yeah. If we just go back to my whiteboard, I'll sum up that a little bit better. So stop share and
Those dogs are well annoying.
I'll stop soon.
Mute your mic, bro.
Oh yeah. How do I do that?
What are you on?
Go give him a massive yeet.
Oh, they've gone now anyway. Fuck it.
Hey!
Hi, Dom.
Hi. Just here photo me.
right. So what we just looked at there, and like I say, you need to have it in its two halves really.
That's
For this
cute.
diode characteristics, this is I, this is negative current against voltage, positive and negative. But we almost want to split this scale here somewhere so that we can go minus 10, minus 20, minus 40, minus 75 over here and have a big scale. And then when we put a line on it, we can have that bit there being 0.7 volts. And then we go all the way over to minus 75 volts. We get this breakdown voltage. Yeah. In some books, you'll see this called the knee voltage, because the graph looks a bit like a knee. Yeah. As we increase the forward bias beyond 0.7 volts, we get more and more current flow. We took ours up to 300 milliamps for that particular diode. All right.
Yes.
Yeah. So I reckon we've done enough for today. We've covered what I wanted to do. Okay. Yeah.
I'm trying to see how that actually looks like a knee. Which bit?
Turn your head clockwise, and then it looks like a knee with someone's foot on the floor.
All right, I'll just agree.
Yeah. That curve at that point looks a little bit like a knee.
Right.
I
Okay.
didn't come up with that idea, but someone who used to be my colleague used to call it the knee voltage for some unknown reason.
All right.
Yeah. Okay.
That's interesting.
No. All right.
Yeah, my
So-
brain is fried.
Yeah, we got a couple of weeks break now for Easter. Yeah. So I'll see you back online on Tuesday, April
21st.
the
21st.
is it?
Yeah.
Yes, April the 21st. All right.
Cheese and
So
rice.
you've got your assignment to work on. So you can all get on with that, can't you?
Oh yeah.
I'll see you. I'll catch you online 8:30 sharp on the 21st. All right.
All right. Well, we'll see you
Good.
then, Mike. Have a nice holiday.
Yeah, and you. I know you'll
Bye.
probably still be at work, but
Yeah.
see you next time. Bye.
Dave.
Yeah.
Bye bye.